Today you're working on section 6.1, which deals with rational exponents and radicals, okay? So a rational exponent is just any exponent that is a fraction or can be written as a fraction. We're going to start off talking about roots, and we're talking about real roots. So we're not going to be looking at imaginary numbers, just if it comes out to be a real number. So if we have an integer where n is greater than 1, okay, so we're only looking at positive roots, and we want a to be a real number. If n is an even integer, so if you're taking an even root and a is less than 0, so the number you're taking the root of is less than 0, you won't have any real roots. If it's equal to 0, it will be 0, and you'll have 2 real roots for anything greater than 0. If n is an odd integer, so if you're taking an odd root, then you're going to have 1 real root for each of your answers, and if you're taking the root of 0, it will be 0. So find the indicated nth real roots of a. So the cubed root of negative 216. Okay, so we're looking for what number can multiply by itself 3 times to give us negative 216. Now, it's an odd root, so I know it's going to have one solution. This is a negative, so now my answer is going to be a negative, and the cubed root of 216 would be 6. So this is negative 6. The fourth root of 81. So what number to the fourth power gives us 81? Well, I know that 9 squared is 81, and I know that 3 squared is 9. So 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So the fourth root of 81 is going to be 3, but it can have 2 possibilities. So I have to look at a positive 3 and a negative 3. Those are my 2 real roots, 3 and negative 3. Fourth root of 16. So the number I multiply by itself 4 times to give me 16 is 2, and it can be a positive 2 or a negative 2. The square root of negative 49. So I'm taking the even root of a negative number, and I know that I'm going to have no real roots. Cubed root of negative 125. Remember, multiplies by itself 3 times to give us negative 125 is a negative 5. And the fifth root of 243. Number that multiplies by itself 5 times to give us 243 is 3. 3 times 3 is 9, times another 3 is 27, times another 3 is 81, times another 3 is 243. And because this is odd, I'm only looking at 3. Okay, so evens roots are the ones that are either going to have 2, 1, or no real roots. All odd roots just have one number as your answer. Rational exponents. So let a to the 1 over n be the nth root of a, and let m be a positive integer. So what that's saying is that if you have a to the 1/2, that's the same as the square root of a. Now with the square root, you don't have to put the 2 there. So a to the 1/3 is the same as the cubed root of a. But sometimes you don't just have a 1 up here, you have a number up here. So a to the m over n can be written as a to the 1 over n to the m, because those powers where I multiply. Also, the top number is your power, and the bottom number is your root, if you want to write it as a radical expression. A radical means you have this square root symbol. Okay, so a to the m over n is the same as the nth root of a to the m power. Sometimes you'll also see that as the nth root of a to the m. It can be written either way. If you have a negative exponent, you're doing the same thing, but you take the reciprocal. Anytime you have a negative exponent, you take the reciprocal. So 16 to the 3 over 2. So my root is 2, so I'm going to have the square root of 16 cubed. The square root of 16 is, and you don't have to write it with the 2 out there on the square root. So the square root of 16 is 4, and 4 cubed, 4 times 4 is 64, times another 4 is sorry, 4 times 4 is 16 times another 4 is 64. 32 to the negative 3 over 5. So negative exponent, I'm taking 1 over. It's the fifth root of 32, and then I'm going to cube this. So 1 over. The fifth root of 32, the number that multiplies by itself 5 times to give me 32, is 2. So 1 over 2 cubed. 2 times 2 is 4, times another 2 is 8. So this is 1 over 8. Evaluate these expressions without a calculator. So same thing you were just doing. So the square root of 4 to the fifth. Square root of 4 is 2. 2 to the fifth is 32. 9 to the negative 1/2. So negative means I take the reciprocal. 1/2 is the same as the square root. So 1 over, and the square root of 9 is 3. 81 to the 3/4. So the fourth root of 81 cubed. Fourth root of 81 is 3. The number that multiplies by itself 4 times to give us 81 is 3. 3 cubed is 27. 1 to the 7/8. Well, the eighth root of 1 is 1. To the seventh power is still 1. 1 to any power is 1. Evaluate each expression using a calculator. Round your answer to 2 decimal places. So you can also put radical exponents in your calculator. So to do that, you would just type in your home screen 9 to the 1 over 5, which is, and we want to round 2 decimal places, so 1.55. 12 to the 3/8, 2.54. And this one I would need to change from a radical to a rational exponent. So that's the same as 7 to the power over root, 3 over 4. Which is 4.30. Same thing on these. So 6 to the 2/5 is 2.05. 64 to the negative 2/3 is 0.06. 16 to the 5 over 4 is 32. And negative 30 to the 2/3 is negative 9.65. And that may seem real simple and easy to just type these in your calculator. You're going to want to practice these without a calculator on the ones that will work without, because you're going to be working with these in equations later on. And the better that you are, the more practice that you have working these by hand, the easier the equations will be. Find the real solution of 4x to the fifth is equal to 128. So I can divide both sides by 4. And I get x to the fifth is equal to 4 goes into 12, 3, 4 goes into 8, 2, and then I take the fifth root. So x is equal to, and the fifth root of 32, it's an odd root, so it's just 2. If it were an even root, it would have to be a positive and a negative. Alright, x minus 3 to the fourth is equal to 21. So I need to take the fourth root of both sides. So x minus 3 is equal to the fourth root of 21. Now, the fourth root of 21 isn't a nice number, so I'm going to have 21 to the 1/4. So x minus 3 is equal to, and it can be a positive or a negative because that's a even root, 2.14. Then I'm going to add 3 to both sides. So x is equal to 3 plus or minus 2.14. I know 3 plus 14 is 5.14, and 3 minus 2.14 is 0.86. Those are my two solutions. Find the real solution of the equation. Round your answer to 2 decimal places. Here I divide by 8. X cubed is equal to 8. Cubed root of 8 is 2. Fifth root of 512. No, what number to the fifth power gives us 512? Not real sure of it off, so I'm going to do 512 to the 1/5. And that is 3.48. And it's an odd root, it's the fifth root, so I'm only looking at that one solution. X plus 5 to the fourth is equal to 16, so I'm going to take the fourth root of both sides. So x plus 5 is equal to, and because it's an even root, it's a plus or minus 2. Then subtract 5. So x is equal to negative 5 plus or minus 2. Negative 5 plus 2 is a negative 3. Negative 5 minus 2 is a negative 7. X minus 2 cubed is equal to negative 14. I'm going to take the cubed root, which is the same as negative 14 to the 1/3 power. So I have x minus 2 is equal to negative 2.41. Now because it's an odd root, it's only this one solution. Then I'm going to add 2 to both sides, so x is equal to negative 0.41. A hospital purchased an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balances method for depreciation, so the annual depreciation rate in decimal form is given by the formula R is equal to 1 minus S divided by C to the 1 over N. In this formula, N is the useful life of the machine in years, S is the salvage value, and C is original cost. What annual depreciation rate did the hospital use? So we know our salvage value is $8,000, that's our S. Its useful life is 10 years, that is our N. 10 years. And our original cost is 50 grand. So when I type this into my calculator, I'm going to have R is equal to 1 minus 50,000 divided by 8,000 to the 1 over 10. Because I don't have any variables, I can type that straight into my home screen. 1 minus 50,000 divided by 8,000 to the 1 divided by 10. So I get a negative 0.20, or as a decimal, or negative 20% if I wanted to write as a percent. Go ahead and write your summary and then work on 6.1.